as someone who got back to an in-person conference over the last 3 weeks, I went to two. I am missing that in-person engagement. So my hope is that we'll be able to get a little bit of that today. So let me share my screen. And to that end, I want to try to make this as fun and entertaining and engaging as possible. So as we go through this, if you have questions, please feel free to throw them in the chat. If you want to come off of mute and ask me, absolutely do that. I want to make this a good time and educational and fun for everybody. So we're going to talk about data today and taming the HiPPO. For those of you who don't know the phrase, what a HiPPO is, the highest paid person's opinion. And that's usually the boss in the room, if you will. But I love data because as we'll talk about here, data actually sometimes disproves that HiPPO's thoughts and ideas. And having that data and having data points will allow you to understand the organization and what the right decisions may be a little bit better. Doesn't mean the data is going to give you the answer every time, but at least having the data will support a lot of really good decision making. As Michael mentioned, I do have a lot of certifications, but I'm a human too, and I want to talk a little bit about who I am and where I'm from. I was born and raised outside of Philadelphia. Feel free to insert your sports boos here. Pretty much every Philly team gets booed at some point, so I'm okay with that. But I decided to go and play baseball in North Carolina, which is where I live today, at a very small Division III school. And I learned while walking to a final December 7th, 1994 in shorts and a t-shirt that I do not like snow and cold weather. And this is actually pre-pandemic. You guys probably remember the polar vortex in that time frame in that winter. This was me and landing in Madison, Wisconsin. I think it was like a high of 4 degrees that day. I was not a happy camper. I do not like the cold weather, I've learned, but I'm all about visiting Minneapolis in the summer. It is a beautiful place to be. A lot of my technical background comes from working with a data center and web hosting company, AIT. I was there for 19 years, started off as an entry-level tech support person, working on Linux web servers and learning things about Apache and SendMail. And probably about 12 or so of those 19 years, I was a corporate officer, either the COO or the CIO of the company. So I had to have my hands on a lot of technology, both customer-facing technology as well as internal technologies, which included running a lot of projects and understanding if those projects were going to yield the return that we were wanting. So a lot of my experience comes from those days. I have an 8-year-old little hockey player. She plays for the Junior Canes. Even in the spring, she's practicing 4 days a week. So lots of hockey games in my future for sure. As I mentioned, I am a Philly sports fan, so Phillies and Sixers. I am not an Eagles fan. I'm a Bucks fan, have been for quite a long time. So those are the teams I support. Feel free to give me flack if you are arch rivals of any of those teams. One thing I learned during the pandemic was, these virtual conferences can be very difficult to keep engagement levels high. And I found that everybody likes a good meme every once in a while, a good well-timed meme. So you will see several of those in this discussion today. And here's generally what we're going to talk about. We'll talk about some examples of bad data-driven behavior, or where there is no data being used. We'll talk about some history of those non-data-driven decisions. And then I want to get into a little bit of data fundamentals, because I think that understanding that allows you to create the foundation of being successful by using data-driven decisions. And then to combat that HiPPO in the room, you need to have a really good data arsenal. You need to have all the things in line that actually allow you to make good decisions and allow the organization to make good decisions, not just rely upon 1 or 2 people. And then hopefully we'll have some time there at the end for questions as well. So if I could everybody put in the chat, why are you in this session? I would love to hear what you're here for, what you like, what you don't like, all that. And I did have somebody, I did this drill at an in-person conference a couple of years ago, and I think their sticky that I put in the back of the room, or that they put in the back of the room, was, "My friends are here and we heard that there's beer being served after this session." So if that's what it is, you're just following your friends around from room to room, that's fine too. It's all in the data. Yeah, Teresa, you're right. You are right. How to handle a HiPPO, yeah. Angel, that's good. If your company's been focusing on data a lot, there's a lot to it. Next learning session from an imposter syndrome. I like that. Yeah, so lots of good stuff here. Hopefully, my talk will actually hit the things that you're looking for. So first, let's just talk about some bad data behavior and what that looks like. And the thing I hear and have always heard, and I've worked in organizations that have had folks that have been doing it forever, and they are the ones that trust their gut. You know, they don't look at data points. They just, based upon their past experience, they want to do XYZ, and that's what they do. And I don't want to say that this phrase is completely wrong, because there is value in experience, right? And what I would say you're trying to avoid here is, I've been doing this for years, we're going to do it the same way, or back when I used to do it. Those are the things that you really want to make sure that are not the common phrases. Well, it's great that we used to do that way, but let's actually look at, some data points before we make that decision, right? And really that leads to scenarios of really what data analysis is, right? A great example of this is, I was in a meeting as I was very young in my career, and I was using some data to kind of determine what the right decision may be. And I told an executive, I said, "Hey, I pulled this report and this is what it says, and I think we should do XYZ." And that trend didn't match with the narrative of what that executive wanted. And because my report didn't match his narrative, then he went on over the course of the next 20 minutes to create these problems or issues with other data that he had been given through the years, basically saying the data that I was looking at was inaccurate, and there's no way that we should trust that, and we should trust him and his answers to those problems. So, like, and this is a very, very hard analogy to make here, but I did want to talk about, bad decision making. Everybody nowadays understands that drunk driving is like not a good thing, right? Yet back in the 50s, 60s, and 70s, there were cars being made without seat belts, and there was, some states didn't have open container laws, and it wasn't as big of a deal. And then obviously through the course of accidents and deaths, it became a big deal. And when you look at the data, like, no wonder there are organizations out there, and if you're from my generation, there was a comment earlier today about Wham and where you were when that song came out. I was in middle school too, so I also too remember Mothers Against Drug Driving and all the drunk driving organizations, the nonprofits that came out that would put commercials on television that would show how bad it was. And there wasn't a lot of data around, these type of stats, but now there is. And so people look at this, and kind of the common thing today is, you're not going to go out and have a few beverages without either having a plan to get home, use an Uber, have a designated driver. Like, it's a very commonplace thing now, partially because, this data has been in front of people for quite a long time, and it becomes now culturally inappropriate to be irresponsible, right? I mean, you hear it in all the commercials, drink responsibly, right? And this has become a cultural thing. Why can't having a organization that is built on data be a cultural thing? And the thing that I keep seeing every time I talk to customers about data, there's decisions that are being made without any data that's backing their decisions. They are trusting management to get the best outcome without, using the data that they're actually collecting, which is another whole problem when you're collecting a bunch of data and then not using it. And then, this is another thing, then decisions are made and then we disagree with the decisions that are made because they don't have the data to support what the decision is. And this is probably the worst of all the scenarios, is on top of all that lack of using the data to make decisions, we're paying for all this data storage to store all the data that we're not actually using to make the decision. So really, I felt like there is a better way to look at this. And in organizations that I've had the chance to either work in or work with, there's some fundamentals I think that stick as important truths for specifically people that are on these teams, whether that be an agile team or some investigative team or some project team, to solve a problem or answer a question or test a theory. And to me, those data fundamentals are really important so that you can have that answer that's accurate to the organization. And the good news is, I think most companies have really good data points. I mean, there is data everywhere. And I'll just flash a few, whether you're using something like Jira or Rally or ServiceNow, there's data points there. Whether you're using some type of aggregator that pulls in information from cloud services, whether you're using, Power BI and Tableau have great ability to pull in different data sources, different data lakes and whatnot. And that's great that there's data everywhere. But the problem is the organizations that are setting up this data structure, it's messy. And it's not that it's messy for people that are, data engineers. And in most cases, it's great that they know where all the data is and how to get it. But the people actually doing the work that are needing to make the decision, there's usually a gap between those data engineers and the people making those decisions. And there's not a lot of help in between. And because that creates a mess and there's stuff everywhere. So hopefully I'm going to give everybody a little education on some of what I consider the fundamentals of data analysis. And once you understand these basic fundamentals, then you can start to connect the dots between the data that your organization may have and creating reports and analysis that allows you to make the best decision and connect in that gap. So let's talk about the different types of data variables. And these are very common ones. This is stuff that you can find online, and I'm not going to try to make this a training course per se, but just to give you a high level, this is the difference between these types of data. And this actually is a lot of the reason why people can't get reports out of Power BI, is because certain data types don't map, right? So there's a reason why this is important. For those of you who have not heard of these before, nominal variables they're just a name only. An example is something like eye color, right? Green, blue, brown, that type of thing. Ordinal variables are things that add create a layer of order. So think of the surveys that you guys may receive that say strongly agree, neutral, disagree, strongly disagree, right? You can put some level of order to those individual variables. And then when you get to intervals, these are like SAT scores, but the problem is there's no absolute zero in that type of variable. And then probably the best variable, but the one that's hardest to get to, because not everything can have a number like this, is a ratio. And this is where you would get something like a pulse rate, right? You can have absolute zero. There can be 0 over 0, right? But there are other scenarios where you can then define these ranges of these variables. This ratio is good, or these are bad. So those are the basic variable types, and I think you can build on that once you understand that. So I don't want you guys to laugh when we talk about average, because anybody that has done any data work in the past knows that there are different types of what people call averages. So most people, when they say average, they're talking about this central tendency, which is great because you want to group data points and find out where is the average, where is the middle, where is the most common, right? You want to understand your outliers, but you want to understand where's our sweet spot, right? And the central tendency characterizes a data set, so you get that central number. And when you have a lot of data, when you have big data sets, you're trying to figure out where the most points are, right? And the problem with that is it can be misleading. And the most common measure of essential tendencies, you've heard this before: mean, median, and mode. And they're the ones that have a strength and weakness to how they're viewed, right? Sometimes they're good to use, sometimes they're bad. The mean is the one most people think of when they hear the word average. And that's the sum of the individual elements divided by the total number of elements. The benefit of using something like this is it's the most popular, way to measure things in business and engineering, computer science. It gives you a distinct answer. The average here is X, and we know what that is, and everybody kind of understands where that comes from. And it's useful in comparing different data sets. So very, very simple, black or white. Is it bigger? Is it smaller? Easily understandable. But obviously those outliers can really inflate or deflate the result, giving you some, extreme value, which really skews the way that things are viewed. And the whole idea of the mean is it has a tendency to pull towards extreme values. And so sometimes you don't want to use the mean because it's not really representative of the data set that you're being given. And so, like, here's a great example. If you have a data set of 1, 2, 3, 3, 4, and 11, 11 being the outlier, and it shows 4, but if you just look at the data set, we're dealing with a super small data set here. If you look at the data set, 4 isn't really representing that group of numbers, right? It would probably be more like 3, right? So if you use different methods, you'll get different output. If you use a numerical result, not an average, you'll get 2.5. So there's different ways to look at these types of outcomes when you're creating reports and when you're setting up data to be used and looked at. Median, if we do that same data set, you're looking at the number of 3. And that's very interesting because the previous one was 4. Is this more representative of what that data set looks like? And again, we're dealing with super small data sets, so we can see the data set, we can see what the median is, and is it representative of the data set. But imagine it's just millions of rows or millions of numbers. It'll be very hard to determine, is this actually accurate or not? And so the whole idea is really to get more even points with the median, half above, half below. And then moving to mode, this is the value which appears most in the distribution. There's some good points here, some bad points here. The good point is it's probably most common, but at the same time, if the outliers are the most common, then that doesn't really give you something that represents the entire data set either. So again, pros and cons to using each of these types of options. So let's talk probability. It's not just a game of counting. Probability is used in a lot of things. Probably most common is things like gambling, or even something simple like flipping a coin and determining if you're going to get heads or tails. The likelihood that you'll roll a 7 if you roll 2 die, how likely are you to get red 32 in roulette, right? And those are all important things when it comes to gambling or having some fun and determining who's going to win something. But probability is used a lot in business. And if you're in the quality area, it is used a ton because you're really trying to, what's the probability you're going to be at 99 or 99.9 or 99.999% quality standard in your organization. And that probability is important. So the quality control example is really important in manufacturing defects. The survey is like sample surveys or sample designs for surveys are used for those random samples to find out which ones are going to get different questions or different outcomes or different options to select. Predictive analytics are ways to get things like decision trees and Monte Carlo simulations, and they're predicting a customer's buying journey, right? You're trying to find out what makes the most sense to put in front of that customer, or what product can we put in the checkout line that they would be most likely to acquire. It's very much used in risk management, and this really comes into place in life sciences. And I'm really glad, as someone who has been to the hospital in the last several years, that they use this type of stuff, because in life sciences, it is massively important. I don't want to use a medical device that only has an 87% probability of me surviving, right? I want to have something that's 100% or pretty darn close to it. And then same thing with stock controls. What's the probability that we're going to run out of a certain product, or what's the probability we'll have to reorder before a certain date, right? Those are things that probability is used in every day, all day. There's another kind of way to look at things too with measure and variability. There's always going to be variability with data. And I'll show this little data, or this little table here in just a second. So the statistics are going to really come from the measure of the variability of the data. There's other functions like the number of times that one event happens, and I look at another table or another chart, and being able to capture correlation between those bits of data. And if we say, for example, 98% of the time after it rains, the sun does come out within a period of 10 days. Now, does that mean that every time it rains, the sun's going to come out within 10 days? No. I've been in Pennsylvania in the winter. There's many times that it doesn't come out in 10 days. But so there's always going to be variability in the data. You have to understand that variability, and is there a cause and effect relationship between those two events, that variability? And this is another area where, as organizations are setting up their data infrastructure and their reporting infrastructure, they may make some correlations that are assumptions. And sometimes when presenting that data to executives, this is where holes get shot in reports all day long, that the data doesn't match their historical experience. And so that variability is really important to understand the difference between things that you should report and then things you should test and see if there's still a correlation between the two. All right, so let's get to some analysis. Now, I think the good news for most of you who are BAs that are doing data work is you're probably already using some tool like Excel or whatever to do some analysis. And I will say, of all the tools out there, I honestly think Excel is probably the best data analysis tool out there because it's so easily available to everybody, and it has almost all of the functions that you would ever need to be able to process data. Now, there are some things that you can't do in Excel just simply because, you know, the amount of volume of data. You may be dealing with something that's 2 million rows. You're not going to be able to open that in Excel. But for most of us, we're dealing with something relatively small, financial information, things like that aren't going to be millions of records. It may just be, you know, year reported information to a couple year reported information. So you can kind of deal with that in a relatively easy way. But the reality is Excel is a really good tool for data analysis. There's a couple others outside of Excel that I would say, and if you want to go down this road of understanding more, one is Python. It's actually a scripting language, and keep in mind that you do not have to be a developer to learn Python. It is a very easy coding language, and this is a very common tool for data analysts and data scientists, data engineers. Along with a scripting language called R. It is not hyper common, but between R and Python, I would say that's the vast majority of people doing serious data analysis work are doing it in those scripting languages. And so you can do a bunch of different stuff with those that you could probably never do with Excel, including dealing with really large data sets. Okay, so let's figure out how to build this data arsenal so that our leaders can listen to us a little bit more and what you need. And honestly, a lot of times, you know, we're building Excel formulas that go wrong, that screw up the whole spreadsheet when we, you know, move a cell or move a line item or whatever. So as you do this, keep in mind if you're using Excel, make sure the formulas are accurate before you show it to anybody. But the first step in terms of this kind of process that I've used over the years to some success is understanding your hypothesis. Now, this means I want to look at how data is correlated or maybe not. I want to create this hypothesis and I want to test it. I do not need to show anybody the data yet. There may be a correlation between the rain coming and the sun coming out. There may not be, right? It just completely depends. But I want to test it, and testing that may take some serious analysis work, which is where you may need, some scripting language like Python or R. And then being able to have the data infrastructure to be able to support that. And by that, I mean, do you have access to temporary infrastructure that you can copy data to? Do you have a data lake? Do you have a data warehouse? Do you have an environment where there is a consistent data pipeline and ETL of that data into your environment where you can actually do something with it and test that theory? But being able to have that environment to be able to do that is really important. You do not want to do this in a production environment. Do not run some SQL query against your production data. Next is to try to have some level of visualization. And that can be a couple different ways. It could be something as simple as using Excel and exporting the information into a chart. It could be something more high speed like Microsoft Power BI or Tableau, or it could be literally, giving the data or your story to someone in your design department and they create the visualizations for you. But at any rate, a visualization output that can be, you can still drill into is really important. And then from that hypothesis, you're going to basically determine an outcome. Either I was accurate or I was not accurate, or, oh, we learned something completely new that we didn't know and we need to do another hypothesis. So to me, the most important part is approach this in an agile fashion. You're probably not going to have the right hypothesis the first time around when you're trying to answer a question. But by the time you've done this 2 or 3, iterations, and an iteration can literally be a day. Once you've done this a couple times, you start to develop a pattern of this is correlated, this is not. You've started to answer some hypothesis, and then you can start to show leadership what that looks like. And you can start to dispel the myth of, oh, I'm trusting my gut. You can actually say, no, we took that into account, we took this into account, and these are the things that we learned based upon this outcome. So people ask me, where do you start in that hypothesis section? This can be almost anything. A great example of a scenario here was we worked with a company who did consulting work, and they had consultants, and they had a myriad of different technologies that were used to track what work was done, how many hours did the customer get billed for those, all that. They had multiple systems that were supposedly integrated. And unfortunately, the reports were saying one thing, but their financial system was saying another. And so they were trying to determine, well, why are we not as profitable as we think we are when we look at certain reports, but then when we look at actually our financials, we're not as profitable. What's the disconnect? And so the hypothesis was, we need to validate why there's a discrepancy between these two systems, right? Is the discrepancy because of the input of the data? Is the discrepancy because of some problem with the cloning of that data to the financial system? What's the problem? What's the source of that problem? The hypothesis is we're going to validate, why that is over the course of several iterations, right? And then the simple answer to that data structure that data infrastructure that I talked about is some simple reports, Excel, basic things. Or you could have something that is really complicated. You may have a data repository, data lakes, data warehouses that deal with a lot of different integrations. And if you have that, there are ways to do that wisely and organize it. But at the end of the day, data is data, and data information and the analysis out of that data can be found. But you need to understand what does the universe look like? Are we talking about 10 lines in an Excel document? Or are we talking about 50 million lines in a production environment? And so real quick delineation, when I've used the terms here already, data lake and data warehouse, they're both widely known and widely used, but sometimes people don't know the difference between the two. The data lake is going to be, it's a big pool of raw data, and they haven't really, that data has not been defined yet and been organized and correlated. Whereas a data warehouse, you'll see that on the graphic there, it shows ETL. That ETL system is basically built to capture the information from the source of where that data resides, Salesforce, Jira, wherever, and organize it so that all the data variables are the same or similar. If it's a date variable or an ordinal or whatever, they're all organized the same. So that way you can run reports against them and determine, what information is valid and which is not. So that's kind of in a little bit deeper dive what that infrastructure should look like. What do you have to work with? What does that output look like? And I want to talk a little bit about visualizations on your design. Just because you have access to write a visual report in your visualization system doesn't mean you necessarily have the design experience to help display the intent of the data. A lot of these visualizations you're trying to tell a story. And unfortunately, some people don't understand how to tell the story. They just think, oh, I want to make this blue, or I want to make this the color of our company and keep it with the brand. And sometimes you need to think about what the data is actually showing and be able to tell the story of that data. So for example, here's a graph. And if everybody could, I'd love to see this. Which one do you think is a better graph, the one on the left or the one on the right? I'll give everybody just a minute to answer that. I see a couple lefts. Oh, wow. Lots of lefts. All right. Interesting. So I will ask this. For those of you who said left, I'll just ask this question. What was the West region's profits in Q3 of 2015? You don't know, because that blue area is now behind the black area and you can't see it. This is an example of, simple but important design work in graphs, right? The one on the right, you can actually see the number, and the number is actually displayed as well, right? But on the left, it's not. Simple things like that. One of my colleagues used to say zebras don't belong on graphs, and the zebras these mentioning are basically these lines across. If you already have the numbers themselves on these bar charts, you don't really need the lines, the graphical representation on the left with the lines going across. So something simple like that, right? It diminishes what's needed, and it takes away from the story if you have them. I would say this is meh. One of my colleagues said this is bad design. I don't know that it's bad. I think it's meh. They have a problem with the common colors on the top and the pie graphs, and then the Christmas tree on the bottom where everything is green and red. I like the green and red, but then again, I come from the IT ops side of the things where red is bad, and I want to be able to, zone my eyes right to it when there's a problem. But this is actually something that one of my colleagues deemed as something bad. And this is an example of kind of better design, more well laid out, aesthetically pleasing, if you will. I like the red, call your eye to it, but I understand why this is actually a little bit more valuable. It does give you numbers here, so you're not hunting for what is that number today. Also, another idea for these visualizations is to attach your goals into it, so you can kind of see based upon where we are and where should we be. That way you can draw attention to something like that. Okay, so we're going to wrap up and get to some questions. I work for a company called SBK and Associates. We are a woman-owned business. We've been around over 20 years, based in Scotts Valley, California. I am in North Carolina. I'm probably the most farthest east that the company has as an employee. But we work with a lot of different technologies, and we do some really cool stuff, including we've broken kind of the things that we do down into these 4 buckets: product lifecycle management, PLM. We do a lot of work with manufacturing and life sciences companies, software lifecycle management, the whole Atlassian and Cloud B stack is a very common thing that we work with. We do tons with cloud, both on the AWS and Azure side. And as you could probably tell, we do data engineering and analytics work. A lot of our work is geared around being able to present, those types of visualizations that I mentioned to executives. Really cool case study that I want to highlight, something that we did that had a really good positive outcome from a data perspective, and it actually ties into this concept of that data arsenal and being able to show things. They engaged with us because they couldn't figure out the profitability of the organization accurately, and the outcome of our work over the course of, I'll probably say, 3 to 4 months, was that they improved their reporting turnaround time. That we made it very easy for them to set up Power BI reports. It didn't take them, nearly a day or two, what used to take weeks. And then the other kind of really important point, they've increased profitability by 8% by being able to accurately understand their projects, what was done, what wasn't done, and where they need to improve. So that way there's this cycle of continuous improvement, as opposed to, well, we weren't as profitable there as we should have been. We don't know what we did wrong. Let's go do it again, type of thing. And so this company is extremely successful now, simply because of the time spent in that data realm. So a couple takeaways here. First thing is, to have a data-driven culture, you need to be multifaceted. You need to understand the technology at large here, and even down, as you saw, into the variable types of that data, because that will allow you to easily create those reports and visualizations to validate your hypothesis. Remember the pieces where you may need outside eyes. This is a thing. Sometimes, even if you have all the right data and you're talking to an executive, sometimes they don't believe somebody that works for them, but they'll believe somebody they're paying from the outside. That is a thing. And then you don't have to fix everything. All right. Start small, figure out how to gauge information, create a hypothesis, iterate for a couple times, and be able to come back with something that's accurate. And if you come back with something that's accurate, usually executives will give you more opportunity, more resources to come back with something even better. And so that is the end of what I have. I know we have a little bit of time. If we want to open it up for questions, I'm open for that. And while we're doing that, I'll leave this up there in case anybody wants to connect on LinkedIn. Yes, Janine, I wouldn't like it if I was colorblind. That is correct. That is 100% correct. Matter of fact, I think that's one of the points that colleague made to me, but I told him, I said, I'm used to the red and green thing, but that is a really, really good point. Any other questions? Really good question, Teresa. What are the best ways to ensure your test data or subset of your production is representative enough? And there was a couple projects I worked on a couple years ago where that was a concern, right? And so what we did was we took some time to just, let's review the data, what's there, what's not, what fields were filled in, what fields were not filled in, what was the highest value in this column, what was the lowest value, what was the mean, median, and mode. We kind of looked at all of that stuff, and that took some time to do. And this was, millions of records, right? And so once we're able to determine, okay, this is representative, that's representative, this is representative, we were able to pick, I want to say it was like 2,000 different entries that was representative of the entire data set. And there is some science behind that too, in terms of how you approach it and the best ways to do that. But that's a very simple way, is look at what data set you have, look at all the values in those fields, and then make sure that your test data is representative of what is in the production data. And that may take, to be honest, that may take you the most time. But once you have that, then you again, your hypothesis can be, are we testing data that's accurate with the way our production data is? And you can validate that you actually did that. And so that's another thing that you can tell your executives, like, hey, we spent the time to do this type of cleaning, so that it's not just, we didn't take just the first 100,000 rows and put them in test. We looked at all the different types of data that we have and made sure that it was representative of our production environment. And in fact, the one that I'm remembering there, they were actually using that to test a part of an application as well that they were building, and they wanted to make sure that the application worked with all the different types of variables and data sets that it may end up getting in production. How do you convince your stakeholders, company leaders, to slow down and give an opportunity to obtain, analyze, and visualize data when they are in a hurry to see a solution, their solution they told you to build? Okay, Mickey, that is really, really important. And it's hard to give you the best answer, but I've been in that situation a couple times. And one of the things that I did in those instances was to ask for what's the timeline that is acceptable to you, which usually they would say something really unacceptable like a week. And you go, okay, well, we could start implementing your solution now, and in 6 months it could be the wrong solution. How long is it going to take us to pivot from that wrong solution to build the right solution? And usually that gives that stakeholder some level of pause to go, well, it's not, if they're arrogant, they'll come back and say, well, it's not going to be wrong. I've never been wrong, or I've been doing this longer than you, or whatever, exaggerated thing they'll say. But if they're wise enough, they'll actually go, okay, I see you're saying, what's the delta between the time we realized we did the wrong thing and the time we did the right thing? Is that a month? Is that 2 months? And usually they're never going to give you, 2 months worth of time, but can you get a month out of that and say, well, before we make any decision, let's spend a month on this to validate what hypothesis we have. That's been relatively accepted. Again, I've still had people that are just very adamant that they want to start on their solution today because they want to, time to market or whatever, solving a problem or whatever. But I think it is very wise to look at what is the impact. And there are some things out on the internet where businesses have made the wrong decision. I'll give you a great example. When I worked at AIT, we were selling a certain type of service for $2 a month. And we had an executive that said, well, why can't we raise it to $4 a month? And we'll just double the revenue on that product almost overnight. And what he didn't calculate was the number of customers that weren't going to pay $4. They would only pay $2 or maybe $2.50, but they wouldn't pay $4. And so that little indecision actually cost the company millions of dollars. And so it's very, very small. You think it's a very small decision, but the implications of that could be really, really big. And there are a bunch of those type of decisions out on the internet. You can find companies that have gone out of business because they made a bad decision on how to price something, how to organize something, how to address a problem, how to develop a product. But that's how I would do it. Look at the time that it would take to pivot from making the bad decision to making a better decision, and use that as this is the time to make a good decision. All right. Well, if we don't have any more questions, thank you guys for having me. I appreciate your time and attention, and hopefully there was some educational stuff here today. If you have any questions, ping me on LinkedIn. I'm there pretty much daily. Thanks, guys.